everybody. This is our educational video number 1. This time we're going to be talking about additive manufacturing of metals and material science behind it. Taking us on this journey is engineer Keren Zohar-Hauber, head of R&D at Technion, Israel Institute of Technology. Hi Keren, can you please introduce yourself and tell us a little bit about your work at the Institute?
Hi, I started my way in the Technion as a bachelor student. I have a bachelor degree in chemical engineering, and after a few years that I was working as a process engineering and engineering company, I came back to the Technion for a master degree in material engineering. And when I graduated, there was an opening position in the Israeli Metal Institute. So I started working here in the Institute as a research engineer. After 7 years, I promoted to be the head of the metallurgical lab in the Institute. And now I'm the head of R&D on the metal branch.
Can you tell us what attracted you to the field of material science and how it led you to additive manufacturing?
Material science is a very fascinating field because it interfaces with so many different disciplines, and its applications are diverse and critical to our modern world. The interesting aspect of material science is that you can see its impacts in many industries, such as medical companies to aerospace or defense, and automotives, and also microelectronics. I think what drew me especially toward additive manufacturing within all these broad industries is actually how it can revolutionize these industries. I mean, the idea that you can build complex components with customized properties and layer by layer open up new world of opportunities. Additive manufacturing is an approach that you can create objects by adding layer by layer of material based on a digital file, and you can produce parts that are lighter and more complex. The EBM uses a high power electron beam to melt and fuse the metal powder particles. The electron beam can be controlled and moved with high speed and accuracy, allowing complex geometries to be produced. The electron beam works in vacuum and higher temperatures. The SLM, with the selective laser melting, uses laser beam to melt and fuse the powder together. The SLM works with inert gas, with argon, and in room temperature. So this is why we usually need to do stress relief after this process. Both methods offer high precision and control over the microstructure and printed parts. Material science plays an essential role in additive manufacturing. It's all about understanding the properties of different materials at a microscopic level and how we can manipulate those properties to meet specific needs. It is crucial for selecting the right metal powder, which can range from titanium to stainless steel. The powder must have the right particle size, shape, and purity to ensure a high-quality final product. Material science helps us understand and control the microstructure that form during the melting and solidification process. By adjusting the process parameters in EBM or SLM, we can influence the microstructure and enhance the mechanical properties of the final part. The post-processing step, such as heat treatment, can further enhance the properties of the 3D printed parts. First, we acquire the metal powder of the new material. The next step, we need to analyze the powder. We check the shape of the powder, if there are any trapped gases inside, and determine the composition to ensure that this is the suitable powder for our process. The detailed studies of the microstructure of the metals helps us understand the properties and behaviors of the material better, and that enables us to choose the best process parameters. The Horizon Europe Twinning Project, SEAMAC, it's actually aimed to strengthen the capabilities of the University of Ljubljana in the field of additive manufacturing through a collaboration between the Freiburg University of Mining and Technology and the Technion, the Israel Institute of Technology.
Thank you, Keren. It was really interesting talking to you and seeing what you do. Would you like to add something in the end?
Well, I'm just looking forward to see the results of this project, and that's it. Bye-bye.